So let's start section 10.1 called the law of sines. Recall that solving a triangle means finding measures of all the sides and angles of the triangle when we are given some information about the sides and the angles. At the beginning of this course, we used SOHCAHTOA to solve right triangles. Now we're going to solve triangles when we have any kind of triangle, especially triangles that are not right triangles. The law of sines is going to help us to do this. So some notation now. We're going to label the three angles of a triangle with these letters: alpha, beta, gamma. These are the first three letters of the Greek alphabet. So I could label this triangle alpha, beta, gamma. So that the alpha looks a little bit like a kind of a curly A, and beta is related to the letter B, but it sort of has this tail on the end. Gamma is actually a Greek G. Greek alphabet doesn't go ABC, it goes ABG. Alpha, beta, gamma. It does sort of look like an alpha on its side, and sort of. Okay, so alpha, beta, gamma, we labeled the three angles. We're going to label the three sides as ABC, just regular Latin alphabet letters. And we have to make sure that across from angle A is, across from angle alpha is side A, across from angle beta is side B, and across from angle gamma is side C. We're going to follow this convention. And sometimes the textbook uses the capital letters ABC in place of alpha, beta, gamma. And if you don't like the Greek letters and you want to just always use capital A, capital B, capital C for the angles, that's fine with me. Okay, so let's start our derivation of the law of sines, this new rule. And so we're going to start with the triangle that's not a right triangle. And let's just go ahead and label alpha, beta, gamma, the three angles. The corresponding sides are little a, little b, little c. And now what we're going to do in this picture is we're going to take that same triangle, but we're going to draw a height or altitude straight down from the upper vertex. And I'm going to call this altitude h. So in my picture now, I've added this h, and I'm going to add some of the other things we had from before. There's alpha, there's beta. I'm not going to label gamma since it's been cut into pieces here by this height h. I'm going to put a b here, a here, and the whole base of this thing was our side C. So what we want to notice is that C cuts our original triangle into two right triangles. And we got a B here, we got a H here, angle alpha here, here's a right angle here, here's an H. Side A was here, and angle beta was here. So I'm copying from the picture up above. We've split into two parts. Now from SOHCAHTOA, we know the following. We can say that sine of alpha is equal to opposite over hypotenuse of this right triangle, that's h over b, and sine beta, which is equal to opposite over hypotenuse in the other right triangle, well, that's h over a. And what I'm going to do is I'm going to multiply both sides of this equation by b to clear fractions, and I get b sine alpha equals h. B cancels on the right. And on the sine beta equation, I'm going to multiply both sides by a so that I can cancel the a in the denominator, and I get a sine beta equals h. And let me just recopy those. We got b sine alpha equals h, and we got a sine beta equals h. Well, we have both b sine alpha and a sine beta equals h, so they have to be equal to each other. We can write b sine alpha equals a sine beta. And now I'm going to take this equation and I'm actually going to rewrite it in a different form. Let me recopy. I'm going to divide both sides by AB. It's a traditional way of writing this, and the reason we're doing this is it's going to be easier to remember in this form. So I'm going back to fractions because b cancels here, a cancels here. I have sine alpha over a equals sine beta over b, and that's really the beginning of what we call the law of sines. It's a sine of an angle over a side equals the sine of another angle over the side. And notice angle alpha corresponds to side A, angle beta corresponds to sine B. It can also be shown that sine alpha over A is equal to sine gamma over C, and also sine beta over B equals sine gamma over C. In a sense, it doesn't matter whether we work with A, B, C, alpha, beta, gamma, the same relationship holds. And normally this is all summed up in just sort of one triple equation. This is called the law of sines. So let's sum it up here. For any triangle with angles alpha, beta, and gamma, and corresponding sides A, B, and C, we have the following. Sine of alpha over side A is always going to be equal to sine of beta divided by side B, which is always going to be equal to sine of gamma over side C. This is the law of sines. It's actually a fairly simple relationship. This triple equation really is a way of saying that you can take any one of these fractions equal to any other. And let's just put our original picture back into place here. So alpha, beta, gamma, I can label those in any way, but the sides have to correspond to the angles. Across from angle alpha is side A. Across from angle beta is side B. Across from gamma is side C. So that's our derivation of the formula. We're going to go ahead and apply this in some exercises in the next couple of videos.